Good day, viewers. Let's discuss vectors and further mathematics. Vectors. We all know that scalar quantities are quantities with magnitude but no direction, but vector quantities are quantities with magnitude and direction. So let's now go through it and check it. Now, vectors. A vector is a quantity that has both magnitude and direction. It is represented by a small arrowhead on top. Okay, it's on top of a letter showing the direction PQ. You can see the arrow on the head of the PQ here. Underlining of letter R, that you can write it as letter R and you underline, that's another way. Or boldly written letters T are other forms of representing vectors instead of the arrow. Now, we denote the vectors in the direction P to Q by PQ with the arrow, and the vectors in the direction of Q to P, okay, by QP. Let's look at this line, for example. Look at the first line there. You can see where the arrow is heading to. We represent it by R with a slash under it. That's one way of representing it, okay. Another line that comes from P going to Q, because the arrow shows that. You can see we wrote it as PQ and the arrow is on the head. That's another way, okay. Now, when it's coming from Q to P, as we have said, you can see the arrow as a QP and it's going to the right direction. So the following terms are relevant to the concept of vector. All right. So let's now move over to scalar product. Suppose we have two vectors forming an angle as shown below. Look at the diagram below. We have a triangle here. On the triangle, we have a direction A. Okay, with the arrow, we have the direction B, which is in the horizontal way. And between A and B, we have an angle which is theta. So look at the narrative here. Okay, using SOHCAHTOA, it means what we have on top here is B cos theta, because cos is talking about adjacent over hypotenuse. Looking at this angle now, okay, this side B is adjacent and the side A is the hypotenuse. So we are using cos. So that's why we have B cos theta as the hypotenuse over there. So the thing we have to do now is that when we want to use the scalar, okay, as the first scenario we have here, so the scalar product or dot product, we call it dot or scalar product, is that when you have A times B, product means multiplication. When you have A times B and the arrow shows the direction, it will be equal to the absolute value of AB. Absolute value means whether it is minus or plus, you don't care. Okay, AB cos what? Cos theta. That is the angle between them. That is the formula we use over there. So if you now make the absolute value, the cos theta, to be the subject of the formula, it means you divide both sides by AB. So you are going to get this second scenario here. Okay, cosine of angle between two vectors. So we are going to have AB with the arrow divided by absolute value of AB. Now, number 3. If two vectors A and B are perpendicular. Perpendicular means they are forming angle 90 with each other. That's the meaning of being perpendicular. So if they are perpendicular to each other, so it means the theta is 90. Then A dot B, that is A times B, will be equal to 0. Why is it equal to 0? Let's look at the formula here. When you have the diagram and there is an angle of 90 between A and B, now you have to multiply and find the product AB. Finding the product in the scalar way, we now have absolute value of AB cos 90, and our cos 90 is 0. Because cos 90 is 0, it means 0 will multiply anything and give you 0. So that's why A dot B equals 0. So let's go to the fourth scenario here. What can happen? If two vectors have the same direction, not perpendicular now, when they're in the same direction with each other, it means they will lie on each other. The angle between them will be 0. And when the angle between them is 0, it means theta is 0. And we all know that when we put the formula, look at the diagram, for example. Look at the first one from here to here, that's A. The other one is B. They are going at on the same plane and the same direction, which means they are parallel and things like that. So it means the angle between them is 0. So we have A dot B will now be equal to absolute value of AB will be what? Times cos 0. And cos 0 is 1. So which means A dot B will be equal to absolute value of AB. That's that about that. Now, if two vectors are opposite to each other, that one is very sure that one will be plus and the other one will be what? The absolute value will be minus. Because now when the theta is 180, cos 180 is still 0, is still 1, sorry. and the sign will now be minus because it will be -1 because 180 is -1. So that's why it is opposite to each other over there. So the next thing now for us to do is to go to representation of vectors in 3 dimensions. Okay, if they have 3 dimensions, how can you represent them? So the way to represent them is this. Now, a vector A with the direction has 3 components in x, y, z direction. So x, y, and z are the one representing each component to make it 3. These directions are perpendicular to each other, where I, j, k are the unit vectors. All right, let's look at the diagram over here and see what we have there. Now, x axis is having I, y axis is having j, and the z which is in between them is having k. So if you have to look at the 3 things, we have to take 2 at a time. If you are using I and j, ij will be equal to, as we have had before, absolute value of I times absolute value of j, because between I and j is 90 and cos 90 is 0. So hence we do not multiply unlike terms under vectors. And their coefficient, as we have seen, that cos 90 is what? 0. Now let's move over to vector product. We have discussed about scalar product. Now vector product. The vector product or cross product of 2 vectors, that is A and B with the arrow, you can see, which signifies that they are what? They are vectors, okay? Which is denoted as A times B and is defined as the product of the magnitude of the vectors A and B and the sine of their included angle theta. Now, when we are talking about the scalar product, the other time we are discussing about cos. Okay, now this time we are discussing about sine. It's still almost the same thing. The only difference is that for vector product it will be sine, for scalar product it will be cos. So now A times B will be equal to absolute value of A times absolute value of B sine theta. Okay, so it means our sine theta as the result of the formula will now be A times B with the arrow divided by the absolute value of A times absolute value of B. So in the second scenario there, if 2 vectors A and B are perpendicular, you remember the other time we also discussed about being perpendicular. Okay, another name we call it here is orthogonal to each other. That means the angle will be 90 when they are perpendicular. So we have to insert 90 here, and since sine 90 is 1, it means in that aspect we are going to have A times B, which is equal to absolute value of A times absolute value of B. Third scenario here, if 2 vectors A and B are collinear or parallel to each other, it means the angle will be 0. We have discussed that also under the scalar products. Okay, when you have sine 0 is also what? It's also 0. It means at that time A times B will be what? Will be 0. And you can also discuss about their addition. Okay, if you want to add them, it's possible. Vector can be added. It is only the scalar that has a product without addition, but vector can be added here. So let's look at vector A, for example. If you're having A1 in terms of I plus A2 in terms of J plus A3 in terms of K, okay, with B, okay, which is equal to B1 in terms of I plus B2 in terms of J and B3 in terms of K. Then when you are to add them, okay, the factor of A plus that of B means you are going to take the element of I together. That is A1 plus B1. We put it under I together. Plus A2 plus B2, we put it under J. We take A3 plus B3, we put it under what? K. If it is minus, we do the same thing as you see it over there. Okay? And when we are talking about the determinant, which we have to apply the wisdom and the knowledge of matrix, and that's what we have there. That's matrix of 3 by 3. So what are we trying to say here now is that the next video I will make, that's why I would like you to subscribe to this channel, like this video, and share with friends. Press the notification bell, and you can look around there or the link in the description below. I will tag the second video, another video part 2 on vectors, where we'll be looking at questions and answers which deals with the application proper. So thank you. God bless you.